Okay, so really quick, this is going to be an update on what you guys need to print for this coming week, so you guys can actually follow along with the robotic build. I'm also going to show you guys a couple of resources at the very end. Preview is right here. This is if you want to get started with Arduino, but you don't have one, you can actually simulate it all. So let's get started with the parts that you need to print out. So I'm going to go to Robotics 101. In here, I'm going to find the robot. Increase my volume a little bit. Okay. I opened the robot file. Okay, so it might give you a warning saying something's out of date. To fix that, you would just push this button up here. But I do know that if I click on this, it's gonna break it because something weird happened and it's not up to date. Let me see if I can find out exactly what's not updated. One child component of this thing. It's probably like the rims of the wheel. I'll show you guys what happens if I click on this. This is the update button. If something if you updated another part in here that this pulled directly into, it wants to update it to latest version. But in doing so, sometimes the joints between all the objects actually break up and they'll be scattered around, which is okay because we're using this base model as a reference of the robot. It's not gonna actually stay together as a robot, but I like to keep it so it's easier to visualize what your end goal should look like. It does take a little bit of time, so if your computer is a little bit if it's struggling, it might be a little scary. I'm not sure if it's gonna make it. I know on my MacBook I actually can't do this, or else it won't compute. So you can see here things have just dislodged from the original position, and things that in the timeline where it asks you for a position. So if I move this, if I move that one part right here like this, you can see how it asks me, do I want to revert position? The importance of that button is that you can see here how this is just a solid cylinder when it should have been something like a solid cylinder with a hole in it. The reason why that button is important is because in certain time instances, you do stuff. You put a hole somewhere. But if you move that object relative to where you made that hole, it can cause issues because the hole might be trying to be made somewhere impossible, over nothing. And you start seeing these yellow errors saying that it's missing its reference. In this case, it's probably missing its reference. So it's a bit I should have probably followed a little bit more stricter CADing techniques, but it is what it is. So for now, this should be okay. I mean, it's not the end of the world for this, but we can go ahead and just see that I'm guessing that the tire did change a little bit in terms of its tolerance, inner diameter here. So if it's 2.54, I just click on this enter. That should match the other tire. Okay, it should. I don't want to decouple too much, but this video is just to show you guys which parts you should download and get ready for 3D printing, because that's the main focus of this. So what I'm gonna do is I'm gonna do undo get last updates, so that it's in the more understandable position. I'll also put these download the files into the resources so that you don't have to go through the same process, but if you want to, you can. I'd just be careful just to make sure that the size of most of these things are correct. Just check it with the numbers I'm about to say as we go through this. So yeah, first thing is the main body shell. So this shell, if you want at this point, if you guys want to make it so that you can attach your top attachments to it, I'd go ahead and just put some holes onto here. When you edit this body, just click on it, look for where the body is in here. So right here, central acrylic frame, it has a dash underneath it. I'll click on that to actively edit this one. I'll put a sketch on the top of the surface here, and let's say I want to put screw holes somewhere here, and I'll put 4mm screw holes. I'll put another one here, 4. And then from there I can just put a rectangle or something just to show there's my climb mechanism. I want it to attach within here and within there, and then I want to say this is going to be off of this wall here by 4mm. This is going to be off of that wall by another 4mm. This one, same thing, 4, head 4. And then I want to center this along this edge, so I'll just put a line, get a line. I'll look for the center, the midpoint icon, click there, 90 degrees, or you get the other midpoint, and I'll turn this into construction so it doesn't actually like bisect this area. So I'll click on the line I want to turn into like invisible line, but it's still reference. Then from there, I will just grab this line, hold shift, click on the central line, and I want to put a constraint saying I want it to be midpoint. Actually, no, I don't want it midpoint because it snaps it directly to the middle. Okay, delete the icon, drag it around still. I want this point, I want this side and that side. I'm holding shift plus the center to be symmetrical. And now if I just modify it like that, that's perfect. And now I can like position it anywhere I want to. If I want it directly in the middle, put it along the center point of the dotted line. So if it's getting a little confusing with all the triangles popping up, just click shift, click on the two things you want to line up. Hold shift, click on two of the objects like the dot and the line, and I could say I want it midpoint on that line, so it's specifically to that line. It can get a little confusing with like geometry underneath it, so that's just one way to do it. So like I have this now, I'm happy with it. The overall shape of the attachment will be like, let's say 30 millimeters by like 22 millimeters. So everything is black, meaning it's fully constrained. From here, I can go ahead and like, I want to make holes, so I'll just pop these out, hold shift, extrude this, extrude cut it through, done. So now you just made your edit to the robot chassis. From here, you can just double click it, right click. You should save in your version, obviously. Don't do this in the master version like I am, but in your team file, just go and do that. And you can save as mesh. Obviously save it if this is your real audits that you want to do. But once you're happy with that, you save as mesh. And then I'm actually gonna undo these just so it's like the exact same base stuff I have. So just Control Z until I see nothing. Just be careful with Control Z. If you go too fast, you know, it might go too far back. Okay, no more edits there. See, no star means that there's been no changes. That's perfect. So I'll double click on the object I want to 3D print, save as mesh. This converts this 3D volume of matter into like slices, into like a surface. Like it's just taking the object's perimeters, the outside like the outside boundary and the inside boundary, and stitching up like a skin. So STL binary, we want binary. Millimeter is what we've been modeling in. That's what the document file is in. We can preview it, so we can see how it's like calculating this, like how it should be fitted. Like kind of looks crazy, and that's the STL file. I just put the high usually. You do not need to turn this on, and then don't worry about output because we just want the file. So I'll just call this like 1 times central chassis. Okay, and then from there, you don't need to be in like the activated components. You can just turn it back to everything. So that one's done. That one's taken care of. Unground this and move all the things, all the things that I printed or have the files for away here. There's a little object connected here. Okay, we'll ignore that. You guys will need to print 2 of these motor clamps to attach the clamps of the motor to the side of the thing. It's important to note that these are not, you can't just print 2 of the same ones, they're mirrored. So you gotta print 1 of each file. You can't like flip it over itself to get another version. It's actually like flipped over this plane, which makes it unique from each other. So I'll save as mesh. I'll say this is the right side. Actually, I don't know which side of the robot's front. Probably like that. So I'll say this left side. Same thing, binary, millimeters, high. And then I'll be like motor clamp. Left. And 1 times. Then motor clamp right. Okay, so these 2 are done too now. Move them over here. Motors are obviously hardware, so we don't need to print those. We do need to print these gears. So So pull these out. This is the one that attaches to the actual motor. So I'll get this motor pinion first. Save as mesh. Okay. So we can just name this motor pinion 1 times. Actually 2 times because we need 1 on each side. 2 times motor pinion. Okay. 2 times of the motor gear train gear for each of the 2 sides. Motor drive gear. Okay, so we got those guys done. So let me just move these over here. You have the bolts here, 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 here. That one, this one. Let's see, can I move those? Okay, so we'll try to take apart the left side because this is like, I'm pretty sure I can move everything out. So out of the bolts, you have those bolts. So we'll just take those out so you guys know exactly what you don't need to print. That's a nut. Remove the nut. Remove the bolt. The nut. Nut. Bolt. I'm just gonna like double click here, there, this one, that one, this one. That's not on the right side. This one. That one, this one. That one, this one. Those should be all the remaining bolts. Pull those out of the way. Get these out of here. You guys have the bearings. You don't need to worry about these clips for now. We'll talk about those later. This is not a complete component, but that's a bearing. You guys have the bearings now. So we'll remove any hardware that we don't need so you guys know exactly what's to be printed. Wheels, we talked about those coming from the RC cars. You just pop them off and pop them onto these new ones. Remove this other bearing here because it's hardware. You don't print or manufacture that yourself, so you just take that and use it. The acrylic plates, these guys are going to be laser cut, so you basically make a drawing. So I guess I'll quickly make a video on that too. Actually, I'll just include it in here too. So you guys have everything you need to start, printing out the stuff you need to build or bring to the meetings to actually build together. There's some bearings on the back and clips, so we'll remove those. Uh-oh, lag. Okay. We can remove the gears, we printed those already. I'll hide this side actually. So that's a part of this. I'll just like hide that. I'll hide all this extra stuff here. With V, I can just toggle their visibility. This is also laser cut, so we'll put that over there. Bearing, get out of here. I took the clip out. Yep. Okay, so we're almost to the point where we're isolating all the spacers. So that's what these are. You'll 3D print these little cylinders, or we might just use PVC and cut them down. They go around the shaft so that it specifically separates the 2 plates from each other, leaving a gap for all this motion stuff to actually, not scrape against each other. The robot's not perfect, so it will have some friction, a lot of friction actually, but this is just to get you guys started. Let's see here. Axles. You guys are gonna have aluminum rods now. They're a little bit softer, so you just gotta not step on your robot and you should be fine. The steel ones look like they're gonna take too much effort with cutting them down, so we're just moving to aluminum ones. You can use a saw to cut them down. Don't worry about the grooves. We might do some lathe work later, and we can actually tap these so the screws can go through. The idea was for the wheels to have screws that go through them, and then put a screw on this side to kind of pressure fit them against the side of the axle. Okay, let's see here. So we have spacers here. This one's a tensioner, so that, you know, if your belt is a little bit loose, you can just raise this up a little bit and tighten it so that the whole belt kind of just has a little bit more tension. That way it doesn't like jump over each of these things. But that's like something you don't have to worry about at the moment. This one's just a middle separator. So all these things we can 3D print. So I'll just like pull them all down here. You don't need to worry about these two things. I removed them from the actual one. That one I forgot to print for myself, so I need to print. We forgot this bearing and that clip, so let me get those out of here. M for move. I'll just grab it along this plane and move it out. Spacer there. Okay, we're almost there. The chain, it's hardware, so I'll just double click it to find it in the hierarchy. Here, optimizing length. Drop that down. Chain, links, all that. I can hide it. Bam. So now we're left with a couple more 3D printing things. So like we need these motor gears. We don't need that. That's this was actually, I guess I forgot to hide it, but this is like this is how I made those. So that was old prototype thingy. Hide that. We just need these guys. And then we have two more spacers here. The spacers are a little bit specific to their size and length and stuff. So this one's specific. There's two of these ones. There's a couple of these ones here. And the rest should be these ones here. One, two, three, four, 5, 6, 7, 8. 1, 2, 3, 4. 1, 2, 1. Okay, I think that should be right. So we just need to take one of these, save as mesh, binary and stuff. Yep, I'll be like spacer type 1, spacer T1, and I'll be like I forget which one did I click on. It looks like the long one, so I'll just say that's T1, and there's 8 of those, so 8x of T1s, 4 of T2s, 4x spacer T2, 2 of T3s, 2, I think I said 2, 2x spacer T3, and 1 T4. Oh wait, remember that we were printing out things for 2 sides, so you might want to multiply all these numbers by 2. So technically this is 2, 2, that's 4, 8, 16. We can go fix that. Okay, so it looks like everything's going downwards in time. So 2, we fixed that. This is now 4. That's 8. And this is 16. Okay, so the spacers are done. We'll move them out of the way in the finished 3D print section. That leaves us with these chain gear sprockets and the wheels themselves. I'm gonna hide the wheels because they shouldn't move with it. It's just I joined them like that, so it's less distracting. I'm just gonna hide it. So we need to 3D print these. They're called roller chain sprockets, so I'm just gonna name them. They're identical to each other. Inner diameter 2.7. Get a calculator out. 2.7. Let me just put the calculator here. It's good to just do these calculations. 2.7 times 2, 5.4. That's a little bit big actually, because we want it to be the same length. Oh, it's because this is out of date. So if we come into, if we go to, we go to this actual thing. So let's take, where is it? We're in this assembly. It's not updated, so I'm just gonna go to it, open it. So then in here it should be updated. So if I just like double click on the object I want to see, isolate it, click on the diameter. Wait, that doesn't look right. 0.2. Wait, inches. Why is my document in inches? .54. So if we get the calculator out again, 2.54 times 2. 5.08. That looks much better. Like closer to the 5mm axle we have. So then to unisolate it, you just double click on the object and you hit unisolate. And then similarly, if we just, you know, hide this part, hide the axle, hide this. I'm pushing V to hide things. If I click on this inner axle, 2.54, same. But the other ones here, if I click on the inner axle, 2.7. So that's why it's out of date, is that this diameter, that diameter are all wrong. So I'm trying to think like if there's anything else that is in this that we may have 3D printed or told to 3D print. I don't think so. I think it's this one. Oh, you know what? It might also include the diameters of these gears. Let's check. 2.54, that's correct. 2.54. So those ones seem to be correct, which is good. 2.54. 2.54. Wait, 2.7. So some of these are updated, but some of these aren't. So 2.7, that's not updated. So we'll just take it from this file here. So roller chain sprocket, save as mesh. STL binary millimeters. Don't need the mesh. Okay. So it'll be like, we need 4 for both sides, like 2 for each side, so total 4. 4 times roller chain sprockets. Hide that. Oh, hide this. We have a spacer here. We don't need this anymore. You can link your parts to make cool like rotations like that. It's a little bit, mine is a little bit incorrectly set up. You can see it's kind of like wobbling. It shouldn't do that. But yeah, so then I think the wheels were correct. 2.54. So just for safety, I'm gonna do it from here. Or I'm just gonna show you guys. I'm gonna open up the base component so it's not linked. So I'll just keep opening it. So that simple component, simple assembly should just look as simple as this. Like, here's the wheel, here's the hub, and here's the body of the wheel. And if you look, the center part isn't highlighted because it's just talking about the wheel. So what we want to take this hub, and then let's just make sure it's 2.54. Yep. So I'll double click on not the whole thing, only the body of the hub. Save as mesh. Yep. I want 4 of these. Basically 4 wheels. 4 times wheel hub. Okay, so we got the wheel hubs, we got the roller chain sprockets. Those were the 2 last things in this pile of stuff, so I'll just move them over. Lagging. My god, why is it so laggy? Okay, they're in that pile over there. We printed these guys too. So I think that's all the 3D printed stuff. And what you basically do when you get to like the mill is that they're gonna load up into a slicer called Prusa Slicer. So I'll show you guys because I need to 3D print one of these two anyways. MakerBot, it's kind of the same thing. I'm just gonna quickly go over like the 3D printing like stuff. The settings, you're gonna have to ask the people who are helping you there to come up with good settings because like there's so many different combinations. I don't think I want to go through all those. So let me go with spacer type 4 because that's the one I forgot to print for myself. My Prusa slicer is a little bit broken, so don't worry about all this other stuff that's popping up in our face. So there's actually one of this object, but I said 2 times, so now I can just come here, add instance. I don't want to print it like this because if I just go ahead and slice it, it can print it, but it's gonna have these like little, it's gonna look a little bit more oval because as it prints layer by layer, and it isn't going to be supported. Right now it has no supports, which is what you actually want to try and practice getting better at. But it builds it layer by layer, and it starts having to bridge over nothing. So at this point right here, it's going to have to start building it. This is how the 3D printer moves. So that blue area is unsupported, so it might like kind of like sink in a little bit. Prusa slicers are pretty good compared to other slicers, so I won't be too worried if I print it like this, but it's not stable. You want a lot of surface area on the bottom. Right now it's like minimal, so you can imagine as it's printing, it might pull it off and like fail because it pops off from this position, and the printer always goes to these coordinates, so you don't want it to fail. So I'm gonna like rotate it on its side. So I'm gonna go back to the placement option, click on those 2 thingies. I got rotate, not that direction, this direction, 90 degrees. I'll ask the printer to optimize it. Placement. I'm happy with this. I'm using PETG. I can go to 0.2 quality because I have time for such a small print. Supports, I don't need any because like right now it's gonna build straight up. So if I just slice it, it doesn't need anything inside of it to like help it build. You can see it just builds straight up and then finishes it. I'll show you an example of something that does need it after I export this G-code. So it's gonna take 13 minutes. I have 2 of them. Download file G-code. Okay. So let me just go ahead and clear this and show you guys a more complicated one. Motor clamps, yeah, this is kind of complicated. So this one is kind of hard to optimize just because there's so many different things happening in a lot of different dimensions. If I do it like this, it's gonna have like all this overhang here on that layer here. It's gonna try and build over nothing quickly. Prusa is great because it actually understands how to go about bridging, which is like this section here in light blue, like the teal blue. It's quickly moving really quickly across there to creating this bridge. So I might just do it like this, but on other printers like around campus, they won't be able to do this because their software isn't as smart for some reason. So that is pretty severe. That's a 90-degree angle. In that case, if I'm using a different printer, I'd like look for the most amount of material. So this is a good surface right here. There's a little bit of unsupported things here, but it's at an angle. This hole might get a little oval, but it's for a screw, so it doesn't matter because I can like just force it to fit. I'll go ahead and rotate or place this face onto the ground. Actually, I'm gonna rotate it by coordinates. Click on this, rotate that way, -90. We have the hexagon for the nut to fit in there, and it won't like, so you don't need to hold it with a wrench. You can just screw it together, and the motor goes in here, it squeezes together. You have these holes to attach it to the side of your wall. And then if I slice this, it's gonna take 38 minutes. It's gonna build like that, layer by layer. Infill, you can change what the infill is if you want to feel fancy, but you won't see any of that. It's more in the advanced settings. And if you really need support, you would just say support wherever you need it. If you need it everywhere, it might generate it everywhere. In that case, if I slice now, you see it supports underneath here where it doesn't actually need to, but it's gonna put everywhere it can, even into here. But you can see that when you remove this, it can be a problem because trying to remove all this, extra stuff. Like if you look in here, this is going through the actual like hole. If you get pliers and try and pull it, that side's not going to go through. Similarly, you just have to be careful of where you put supports. So yeah, that's a little bit of 3D printing. But I need you guys to print as much as you can as soon as possible. The most important part is the central piece, but if you need to make modifications to that, that's fine. So yeah, just try and print stuff, at least one version, as soon as possible. that's the 3D printing. So let's talk about getting your files ready for laser cutting. So we have 3 parts here, technically 4. And these guys can be invertible, so like I only need to cut these 2 and they can fit onto each side. It's orientation, like this plate's on the outside, but I can also just move it here to get the other side. So it doesn't matter too much on if I need the mirrored versions. So I will start with this piece, make this really simple. So I'll just double click on it, file, new drawing from design, because this is our design workspace. Might get a little laggy. If you ever see this black box come up, do not click anywhere. Your computer will crash, or your program will crash if you click anywhere else. I want to select what I want. I want this part here. I want to create new. ISO's good. Standard. Uh-oh. If you are fancy, you can kind of just browse. I think I have in my 2310, but if I it's gotta be in here somewhere. Maybe capstone. Okay, I can't seem to find it. You can just use the standard one. Mesh T-spline surface will not be included in this drawing. Don't show me again. Okay, we're in our drawing. I think it's still loading because I don't have a piece of paper in front of me yet. Oh, there we are. So you can in the end we're going to delete everything other than this, so the laser cutter knows exactly. The first thing it's going to want to do is place a base view. I want to place the base view so I can see the top. So I'm going to start with the top. I want the scale 1:1 because we want it to actually match the robot. From there I can just make sure it's yeah, visible and hidden edges. And I don't want hidden edges, I just want visible edges. And then I can hit OK. I'm gonna delete, just click on the edge here, delete that, and delete all this extra stuff. I'm gonna go ahead and just double click here. Can I rotate? I'm gonna rotate around this by 90 degrees. Oh, okay, rotate again. Okay, and then I will also you guys can take the liberty at this point to write in like some stuff here. I would highly recommend just writing down like our sponsors. So for this semester we're sponsored by Autodesk, so I'm gonna write down here, powered by Fusion 360 Autodesk. And then below that you guys can write your team names, like your team name or your bot name. So I'm just gonna leave this one kind of blank for now until I talk with my team on what they want. So I'll just center this. I will also center a symbol. Ooh, interesting. You guys can play around with this, but if you want to change the font, you guys can. So I'm gonna increase the size of this a little bit for me. I'm gonna go like maybe like 10. Maybe that's too much. So 7 sounds good to me. It fits within the actual space that it has. And then maybe change the font. Not good with fonts. pick a random one. So yeah, let's see. I just put Autodesk, and then I want to like see if I can center this. So I'm gonna like lower that to the same size of that. There should be a, nope, no, that's pretty bad. Somewhere it should have like a center vertically, but I'll just like manually like put it in here. If you guys want to know how to put it perfectly center that, you guys will probably have to Google that. Or maybe I found out like right here. I'm just estimating it. So at this point, we'll export as a PDF, or I'd export as a PDF or a DXF, I think, or I'm not sure. PDF is just safe bet. So then you can edit in Illustrator. So yeah, we have this. We want the entire sheet. We want to open the PDF so we see it. So it'll be like, what is it called? Laser cut panel bottom. So just do that. I'll come over here and I will go to my Citrix. So this is the VPN thing. And the reason why is that you guys can actually have access to Illustrator, so you can get your files ready for laser cutting before you can get to the VMA shop. So you're really ready for it. Also, this is a review for people who don't know how to laser cut, but very high level because I can't show you the machine side. So this is our PDF that we have. Looks perfect. We just want to cut out, you know, we want to cut out this part, powered by Autodesk. So I'm gonna go to the library computer. Also, if it's not in here, just go to your desktops and you'll see like all the computers you have access to. Interesting. Okay. So it's mycloud.gotech.edu. I think that's how you get to the Citrix, by the way. I just remembered. In case you're new to it. Okay. This is one of the virtual computers that actually has Adobe programs. I used to have it on my industrial design computers, but they somehow like cleared everything, which is frustrating. So I'm just using the library ones now, which is great. At the same time, while that loads up, I'm gonna download, upload onto this virtual computer from my downloads, my laser cut bottom PDF. I'm gonna upload it. I'm gonna make a new folder on this desktop named Robotics 101, Rob 101. Laser cut. Oh my goodness, too much. Okay, that's fine. I'll just name it Rob. And then I'll go to Rob. If you're not sure where it is, if it doesn't pop up for you, just go to your desktop. There's Rob. Okay? And it should upload to this. I'm not sure why it opened up in VS Code when it's a PDF. That's really strange. There's the file. I'll just right click, open with Adobe Acrobat. So we have it here. Obviously this is not all the formatting we need for laser cutter. Adobe Illustrator. We need to, you can see here I made a couple of other versions for robotics, the panels and stuff. We're gonna start with a custom, more presets. Custom. The machine is 32 inches by 18 inches. We need to match the size of the machine that we're going to be laser cutting onto. RGB color mode is important. High is what you want it to be at. It's in inches, so I'll create. From here, I'm gonna import. Actually, I ain't gonna copy and paste it once I'm ready. So what I'm gonna do first is open the file, laser cut panel, laser cut stuff. I'm gonna open it with Adobe Illustrator. It's not gonna. Oh, okay, well that's unfortunate. We'll just get rid of this here and I'll just retype it. I think it's like fonts and transfer, but that's why you should watch this video all the way through so you don't have to do more work. So this is our file here. We want to change the color to red and make sure it's really thin. So what I'm gonna do is copy this, paste it, because this might not be RGB color format, but we know that this is RGB color format. It does say RGB here, but I'll just do it in here anyways, so you guys can see the scale of the machine to the part. Alt and the scroll wheel gets you to zoom. Hold spacebar down to pan, and I think middle mouse also pans, but those are the two things you're gonna want to know how to do, because otherwise you might get lost really easily. So pan, and then hold Alt to zoom in. You'll get used to it over time. Click here, paste. There it is. We want the stroke color. We want it to be red. Don't go for this red. It's cyan, magenta, yellow, and black red, so it's not perfectly red. We'll go to this panel here. Oh, wait, not that panel. We'll go to the color palette here. Art changes to RGB. One second. Yeah, if you just click on here, you can change to RGB. Okay, why isn't it? Why is it cyan, magenta, yellow? Release mask maybe? And I'll check the layers to see if there's anything weird happening in here. What is this? I don't want that, just delete that. To select things into the layers, you just click on this little bubble. So that's the object I want. So it has all the different parts of the path I need here, like that part, this part, that one. So you can see here, like that's that section. It's all a bunch of like little lines. So that's good. Now I think I should be able to. Properties, stroke. Okay, perfect, RGB format. So you gotta remove the mask. RGB, so 255 is pure red. We talked about this in Arduino 00. It might give a warning, but if it doesn't, that's great. We want the pixel size to be 0.001. Really thin, but you should still be able to see it, or else you did something wrong. Fill should be nothing, so empty. And then let's just think about it. If it's gonna cut here, the red path, it's gonna cut all the way through the plastic. So that means that this little circle in here is gonna drop out. That little circle in here is gonna drop out. We don't want our text to be red, or else we're gonna have holes in there. So we're just gonna cause that to do a raster. So this is a vector cut. It's gonna cut all the way through, and then black is usually the color for text. So I'll just put text here, and this is good. I can now center it myself. Well, I don't know how to do that. If you want to know, Google it, because I don't know how to do it. So I'll just double click this text. I'll be like powered robotics, robotics 101, powered by Autodesk. Change the font size, center this, center that, and then oh, I can see the actual things now. Natasha's probably like upset with me if she sees all these fonts. She'd be like, that's not the right one. Ooh. You guys can pick whatever font you want. Just put on there somewhere Autodesk, because they did help provide funding for this robotic project. Okay. And then that looks good font to me. I may increase it a little bit more. Oh, too much. Okay. Oh. Delete that. I have this here. And then the fill is black. We don't need a perimeter, because it's just gonna be like etching it, so it's gonna go side to side like a 3D, like an actual printer, like a paper printer, and drop ink down. But instead of ink, it's just like a high intensity laser beam that's gonna remove like a small layer of plastic, so it's like etched. So fill should be perfectly black. So if I hold shift, oh wait, it doesn't work on here. We want to go to the little palette here. It's 000 for black, and then 255, 255, 255 is white. So I think this is good now. It's on the it's the correct size on our laser cutter. It has a text, it has a raster. So at this point I'll just save this. I'll be like bottom panel Rob. I'll put this in my downloads. And then also make a PDF version in case I don't have Illustrator there. You can just print it directly to the robot, into the machine. So WPDF Robo panel bottom. Perfect. Okay. So we went from that to whatever we have now. And you basically are ready to go to laser cutting and cut that out if you have the materials, which you guys should have. And then in order to take this to your computer so you can download it, you just have to download. And from my desktop, or I guess I'm just gonna Rob here, take this, and I'm also gonna just say all file. Okay, so I'll take, is it here? Maybe it's in my downloads. Yeah, these two, not that one. That one was the original. Let's take these two thingies. Open. It'll ask me where do I want to save it. I'll save it right here. Bottom panel, PDF file, and an Adobe file in case you need to edit it at the shop. Save that. So now you have both. Just gonna do this thing because it's downloaded. So at this point, I can close down everything. Don't need that. That's just our template that we used. And then that should be it for laser cutting. Sign out. Thank you for Citrix. Okay, and now I can save this one as here if I want to. I can be like Rob bottom panel. It should populate into here as a drawing right there. So if you make an edit to this part here, if you make an edit to the main robot file here, like if you actually write the text directly into the CAD file, you'll get the same update button somewhere here. Similarly, like you see how this one has update, you'll see the exact same thing for the drawings. And that is parametric design. So if you change one thing here in the main model, it should update everywhere else downstream. So I'm gonna close everything without saving it because I don't want to mess anything up. And by this time, you guys should be working on like your motors and the motor drivers, so we can get started with coding it. The axles will be covered soon. Those are aluminum. We'll talk about cutting them down, as well as putting these grooves in. But yeah, hopefully you guys can get all these printed, and get the other two drawing files for these two done yourselves. And come check them out with us. Like, see if you want us to check it to see if you did it right. Just let us know. I think that's it for all the CAD and manufacturing, but let's talk about a little bit of how to get started, like how to get familiar with coding. So right here, I just, we usually talk about Arduinos a lot. You hear us talk about Arduinos a lot because they're just so cheap and simple, but sometimes you guys might not have access to them. We're not going to be using Arduinos, but that doesn't stop us because this can act the same way as you do with regular other microcontrollers. So this is called Tinkercad. In here you can simulate how you wire things up and see how things work. If you're curious, like what does a button do, or what does what can an LED do? LEDs, buttons, resistors. How Andy showed you guys in fritzing. Like you can set the resistance, like 330 ohms. There's coloring for each kind. Batteries and all this other stuff. Motors, ultrasonic sensors. in case you don't want to actually have to go get it. So yeah, this is just somewhere you can start plugging things together. Like if you guys want to try and learn Arduino, you can be like, okay, I want to make a button turn on this LED. So for simplicity, I'm actually gonna just like delete everything. Delete. Yes. I'm gonna get Arduino, plug it in. I'm gonna get a resistor, an LED, a breadboard, and a button. Grab the LED. I'm gonna put, I don't need a wire. I'm gonna put this into the positive pin. Can I rotate this? Rotate R. Yeah, I can. Okay. Put that into the positive pin. I thought they can usually reach. Okay, I'm just gonna put it up here. Positive to the positive rail. And then you can also change the color of the wires, I believe. Here. No, positive is red. And then you can tell the positive because it's usually like the longer one. So if you think about it, this one's bent. So therefore, if you straighten it out, this one will be longer. And that's the anode and that's the cathode. Just know that the longer one is positive because direction matters for diodes like this. Diodes allow current in one direction. I'll put the resistor to the pin, or I'll put the ground and I'll just connect those two together. Change color to black. And then from there, I want this button to control when this thing turns on. So, well, this one's gonna stay on actually. So if I want to delete this, actually delete that. Actually, get the start over. So this one's gonna be plugged into here, like that. So then this, if I rotate this down, or just pull it down like that, I can maybe just reach. I don't know if it detects that to be connected into both here. So for safety, I'm just gonna go like this, get a wire, come around, bring it down, and plug it into this channel here, so that it's all grounded. From here, I'm gonna make a button. I'm just gonna plug it across the center point here, like that. And then I'm gonna connect. This is an analog thing. It can be digital actually. So a digital lets you do true or false inputs. Analog lets you do like a float of data. So like 1, 0, like 0, 0.1, 0.2, 0.3 to whatever number. Digital, which is like these ones without the squiggly signs, are like either true or false, so like on or off. And these squiggly lines just mean that it can technically act as an analog by doing some fancy electronic stuff, and lets you simulate floats. Not simulate. It lets you collect float. So we can tell it to connect to 3. I'm gonna tell 3 to be what controls the LED's current state. So you can connect that, and this line connects all those together. The button, I'll connect this to analog, but it doesn't need to be. It doesn't need. Actually, for this I won't make it analog. I'll make it digital. So I'll just connect it to 2. You want to leave 0 and 1 alone. They're for something else. They're for Bluetooth later. Do you want to be fancy? You can straighten up everything. Okay, and then I'll connect. You usually link up these two guys. And then from here, I'll connect this one to ground. And then this one to the positive power, 5 volts. There's also 3.3 volts. In case when you look at all this stuff, you should like read carefully, like what you buy, like what voltage it should run on. 3.3 is another common one, but 5 volts is usually more common. We put this resistor in here so it doesn't like let this LED turn on too bright and cause it to die faster than it usually would. We want to preserve its lifetime. Otherwise, if you don't care, it's fine if you run it for a couple seconds or a couple of minutes. I don't really know. It usually I don't even put resistors, but this is good practice. Okay, so this connects to the computer. This is if you want to plug it to a battery, so you don't need the computer power. This is reset button. That's your microcontroller. The pinouts are here. There's a couple different ground points, 2 power thingies, analogs and digitals. A couple other buttons on here do stuff that I don't know how to explain. VIN is like if you have a LiPo battery, like a big battery or something, you can either connect it to the barrel jack or directly into VIN for voltage in. Okay, so red here. This one's a signal wire. This one's red too. Red. Red. Signal wire here controls LED. I'll name that orange. I'll make that orange. Input, I'll make it green. That's ground. Okay, so pin 3 controls the output of that, but we need this button to turn on something in the code that tells pin 3 to change from low to high, from off to on. And we need this to become connected to the positive. Try to remember. I do believe that these two are the same connection. So one way to just check that is like if I connect this wire to like there, I'll grab like a multimeter. Negative goes to ground. Positive, I'll put it to this side. I'll start the simulation. We read 5 volts, so that means this thing is connected to over here. So this is all 5 volts, and when I click on this button, it connects the 2 pins together. So if I grab another multimeter, I connect the negative to ground. It's a reference. And I'll connect this to over here. We should see 0 volts. Volts. Start simulation. So that's like basically 0. That's like really small millivolts. And if I click this, it puts these 2 things in contact with each other, so it connects them. So that's 5 volts. At the same time, when I'm hitting 5 volts over here, it sends the signal as high to pin 2. And that triggers something in the code to change pin 3 to become like on or off for this guy. So I'll leave these things here just so we see how things work. Let me organize a little bit. Actually, I would like to be able to see it, so. I'll put this one up here to showcase that it's getting I'm doing great. Okay, so that's connected. In the code, there should be like nothing. Oh my goodness. So this is block code. We do not want block code. We want the text code. If you really need to, you can rely on the block code, but I don't know. I don't think it's gonna write it as I do it. But right now it's just saying it's C++ code. In the setup, it's starting up everything. Pin mode LED built in, so it's usually pin 13. It's just like the built-in one, which is like this L, I think. It's connected to pin 13. Why is it? Okay, pin 13 is connected to L, so that's what LED built-in references. But we can come up here. Why can't I type in the code? Oh, is it because? Yeah, I don't want the block code. Okay, so come up here. I'm gonna type in like LED pin. I'm gonna say this is going to be pin number, so the LED is connected to pin 3. Put semicolon. I'm gonna put button, so button pin equals pin 2. And in setup, we need to tell like what are these pins doing? Are they inputs or outputs of data? So pin, LED pin, button pin, LED pin is output, yes. Input for button, all capital. It's within this loop of void setup. I can also move that there so it's easier to see. Condense it down, separate this a little bit. Put that up there. I'll write in here initialization. Setup, double space here. Put this here, bring that up. Condense. Okay, so now right now it's gonna, I'm gonna remove that. Turn this one on, put that there, put this here. Digital write is just doing on or off, like true state or high, like low or high. That's why I can't do like fancy like dimming, like intermediate values. You can't do half brightness. But we connected to pin 3 for a specific reason, because that squiggly line means that we can send out intermediate values, not just 1 or 0. So void loop, this is the code. So it goes down line by line, goes through this once, goes through this constantly, and so in here we want to write our code. It says wait, delay, waits for that many milliseconds. So digital write to our pin, LED pin, this variable stores the pin's position 3. We know that this is an output, so then we can control it with digital write or analog write. So high or low. So let's just see what happens. Oh, don't want to save that yet. Start simulation. Oh. So I forgot to type in the type of data it is. So it's constant, const, int. What else is it yelling me at? Probably all that, yeah. Hopefully I did it right. Okay. Turns on and off. On and off. Okay. Okay. So that means that we wrote the code for turning this on and off. Okay, and let's stop the simulation. And since we know it's a analog, it's a squiggly line, we can actually change it from like low to high slowly. So I'm gonna write in here void loop for I plus, and then put this in parentheses, and then open up a squiggly parentheses, and close it off there, put down 1, tab this in 1, for I plus, and I need to search this up, for with iterating okay, I'm not sure. Just keep Googling, but I don't want to waste too much time. So for I, comma, I is less than or equal to, I'm just like less than 100, 100 and 101. So it does 100 intervals. It skips the first one because it starts at 1 and not 0, like MATLAB. It's gonna keep iterating as long as these two conditions are met, and then it runs into here. So if it does that, for this, it does that. For, actually we're just gonna write if, and then down here within this loop we're gonna put like a else if else else we're gonna say I equals 1. I don't know if this is gonna work. I'm just trying things. I equals 1 colon. Yeah, that should be good. Yep. And then this should do the same thing. Okay, rep. Expects. Okay, so I think it expects 1 here and 1 here. I was not declared. Okay, so I have to also specify I up here. I have to initialize it, or else it's not going to know its actual thing, right? I'll put int, not constant. int I equals 1. What else are we complaining about before the else? Okay, start simulation. Okay, off, on, off. I mean on, off, on, off. So same thing, but we're also gonna change this now to analog right, analog right, and it's the same pin. We're gonna put I as the value here, so it's gonna iterate from 1 to, well, we need this to be 255, so 256, so it's max brightness. And then I'm gonna put delay smaller so it's faster, so 50 milliseconds, actually 100, 1/10 of the time. Actually, I'm gonna set this to 50 so you guys can see that it being off it won't matter, like it won't be as long. You guys can see a difference how this one line of code can change stuff. And then you can just be like, waits for 100. It's good to just be able to update your comments. Okay, that all looks good to me. Okay, start simulation. It's going really fast. It's just really hard to see. If I decrease this, wait, what happened here? Why is it so low? Also, can I change the color of this? Let's be blue or white, or it's so hard to see actually. Okay, let's try a NeoPixel stopcode, and let's go to here, double click out. LED. I think this the NeoPixels are cool, but I can't do that right now. It's a little too complicated. So let me just replace that. Cathode is ground, so this just replaces that. So we'll just put this one into where this pin lies up because that's ground. I think, wait, hold on, cathode. One second. Anode, cathode. Cathode is ground, yeah. We'll put that into the ground. We'll leave this here. This should be 330, I'm not sure why I changed to 1. This still controls the blue. And we can actually just we can just copy and paste the code to do the other one. So I'll just connect this one up here, just so it's kind of interesting. I'll get ready to connect this to other ones here. So 5 is another one that can squiggle or have the multiple data types. I'm gonna stop talking. Those are not right words. Connect this 9. I'm not gonna do anything with the code yet, but it's just ready for when we do copy and paste the code to just kind of increase the capability. Okay. I'll make these purple, just so that these are extra stuff we haven't done yet. Okay. Code. Okay, start. So we can see it's kind of going too fast. So let me see if I can just change the speed to 500. Half a second. It's getting darker in color, which means it's more consistent. I don't know, more that color. I'm gonna go ahead and just get rid of delays now, or I can comment them out with double /. And we should now, if I just hide, I don't want the delay even, I don't want the flicker, so I'll just get rid of that. And now I can just ramp it up in color, in brightness. Uh-oh. I don't think my else condition worked. It seems to be stuck there. For Okay, increment here, condition, initialization. Okay, so condition and increment. For int equals 1, I is less than or equal to that. Okay, so I have to put semicolons to separate them. Okay. So for top code, for I less than or less than that. I already initialized it up here. Colon I plus plus. Start to simulation. Oh yeah, and then I didn't actually read about like how to. Okay, 4. Let's change this. I'm gonna get rid of the else. Stop simulation. This is what you guys are gonna be doing. Probably like something like this. For that. Does that. I'll put like a small delay of like 10, like in the code example. Get rid of all this extra stuff I don't need anymore. Run. Okay, so it did go up. Oh. Okay, so it does seem like it's resetting. So if we want to know what it's doing, we'll look at the serial monitor, but we need to tell it to print. So we're going to stop the simulation, come into void setup, and do something called serial.begin. And then we'll set the rate 9600 and serial print line, and then we'll say I want to print out this variable, this I variable, semicolon there. Start. Oh, have a habit of pushing Control S because you don't want to lose your progress. Okay, so it's going up. Okay, so reset, but it's way up there still, so it's not really doing anything. So we need a way to reset this back to 0. So right here, if it does 4, let's see if that does anything. I'm just gonna put it back. I don't know right now. And then if else should work. Else it should work like this, like honestly. Okay, look at the 4. Oh, okay, so you know what? We're just gonna copy this. I get rid of the initialization at the beginning. Basically, when it comes back into here and it's not this case, it might just reset it to 0. Instead of us having to do some weird stuff. So I'm gonna put this as a 4. And I don't know if it's gonna be different. I mean, for this stuff. I mean, it should work. Okay. Okay. If we want to plot. Yep, that looks correct. If you change things like speed. Should go faster. If we just get rid of this, it should go really fast. It should. Uh-oh. Oh, it's so fast that... Okay, yeah, it's going faster. Okay, so let's see what we can do here. We have 2 other pinouts to control the R, G, and B values to get those colors. So I'm just going to copy and paste LED pins. This was blue. blue, that's green. Uh-oh. Green, connect to 5. And then red is connected to 9. And then we also have to update their pin types. LED's output. Oh, we didn't even use the button yet. So button 2, and we'll also do like an analog read in. So we will do, we'll talk about helper functions now. So I'll make a new function called void. And I'll name this like get button, and then parentheses for function. Open the curly braces for the stuff inside of it. In here, I'm just gonna write like analog read. I think that's a command. Yeah, analog read. This is just how you run that one. So it's like another. It's just basically another one of these things we're making right now. It's just another one of these that are already integrated into the coding software, like another function called analog read. So this could have literally been button read. Actually, I'll do that. Button read. But this one's not included. It's the same thing. So analog read, but we're gonna call it a helper function for us. Analog read is a function, so we'll do this, and what its input are, like the inputs to this is it just needs to know where to pull the data from. We have our pins. We connected it to pin, like these are technically the analog ins here, but you can use digital ones to read into. So pin 2 is going to be what we get. When is it full power? That's 1023 data bits, like something data bits, and that's a high state. Low state is not 0. It's actually like I think 3.3 volts. So whatever that is in the level for analog in. If that doesn't make sense, don't worry about it. Just Google it or something. Watch a YouTube video. Analog read, and we know that the button is just storing that position too. Put this in here, semicolon here, and we can name this data equals that. And then let's see here. If I remember what Natasha said last time, his parentheses are to put an output. So if I write data here, when I call this function, it'll return data. So I'll put data, button right here, Control V, open the parentheses so it executes. I don't think you need a semicolon on that one, but then I can say data. Actually, I don't even know if I need to type in data. So then I'll put in serial print instead of this number, I'll put data. And I'll see if that updates. Yep, and that should work. Because whenever it gets to here, it'll jump down to this line. I really think this is an input of data, like we need to put something in here. So I don't think it's right, Natasha. So data is going to just be what goes out. Button read. I'll just name this data to, I'll just name it like beta or something. I don't know. Oh. Why is it, okay. Beta. Because I don't know if it's going to be same as data, but we'll check here. And we'll put like beta. And I'll put like a tab here, /t, tabs in print line. Yeah, /t. Oh wait. That's too much effort right now. I'm just gonna, if that doesn't work, I will just put a bunch of spaces. Oh boy. Okay, so I'll just put a bunch of spaces. Or I might have to just actually like concatenate. These spaces don't matter. Okay, and it's yelling at me here because I don't think I initialized this thingy called beta. So I'm just gonna write constant. I mean int. It's an int, yeah. Int. Int beta. It's also yelling at about data probably. Int data. I'll just set to 0. Okay. I was not declared. Void value not ignored as it ought to be. What? Okay. I'm not sure, guys. Void loop. In function void loop. So in here, error. Void value not ignored as it ought to be. Error. I was not declared in the scope. Okay. Oh my god. Habit of control S. This is getting stranger. What? Oh, I forgot to pull in here. It's here. This is kind of long recording, but it should be fine. Void value not ignored as it ought to be. What does that mean? So if I'm not sure, just copy, search. This is what you need to do. Okay. For this, yeah, stuff is happening. What is the difference? What is all this? This looks complicated, whatever this is. What in the world? Okay, maybe it's because get rid of anything that stores it into there. Get rid of that. We name this so whatever it pumps out, it pushes into here. It's initialized. This is ridiculous. forgetting like a colon somewhere? Okay, maybe I can't do that either. We got rid of 1 before 4. Okay, so I guess I need 1 here before parentheses. What parentheses? I don't need beta anymore. It's not a thing. Don't need the I. That was never a problem. We don't have that stuff. I'm confused. I don't know how it's gonna take any data in. We're gonna figure this out. Benji. Oh my goodness. Hopefully you guys weren't just shouting this entire time. So we were controlling pin blue. Oh my goodness. Oh my goodness. Okay, slowly we're getting there. Okay. Okay, it's not the right data type, so button read pops out. Maybe a float, but it's just on or off. This is frustrating. Button read, it does that. Button pin. Oh my goodness. Why? Oh my goodness. What does this mean? Okay, this worked without it. Yeah. Okay, so if I just grab this, I pop it into here. Oh, wait. Oh my goodness. We want data coming back out, so we want to. So then, if nothing, void if nothing is returned. That's why it says void. So we don't want to void it. Okay, so then we want a function like this. Okay, oh my goodness. So I'm gonna name this one beta to the void, beta equals button read. Yep, and button read is just that with the other thing inside of it. We want to be fancy. No, we don't need to be fancy. Just get to work. So then this would just be beta. Well, we can leave it like that. Should work. Okay, now. Did I spell it wrong again? Beta, beta. Might have to cut this out. I don't know. Okay, so oh my god, where is this one right now too? What? Oh my god. That's weird. I'm not even pushing this button. Why is it changing? Oh, okay. So it started up. It's constantly checking it. So if I push on this, it go. Wait, what? What is it doing? Wait, what? Okay, let me just push on it. Not doing anything. Okay. What is it printing out? Beta? Why is beta changing? It's doing that. Constantly checking it. Oh, it's constantly reading it. Okay. It's constantly reading it. But it's really noisy. We don't have a delay. This is really strange. Why could it be doing this? Let's just try connecting this thing over to here. Okay, so that does have an effect. It's really low. It's really noisy. But if I click on this, we definitely see that the voltage goes into here. This connects to D2. Button pin is 2. Input. Analog read. Maybe it's not analog read. Keep that one. Digital reading of PWM on Arduino. Yep. Interesting. That's not external interrupts. That sounds more complicated. And that looks even more complicated. Analog right. Oh. Rip. Okay. That explains a lot. Okay, so we got to change this button pin to A. Let's just say A0. A0. And then that means we need to change this button from connecting here to here instead. Okay, so now, wait, that doesn't make sense because this was just on or off. Okay, I should get rid of that short circuit. Because we want this one to turn to high. Oh, okay. Okay, I think we're almost there. So now, the reason why it's not doing anything is because we haven't written the overarching, like, if for this, but after the button rate, if we do it if beta, and this is conditional, if beta equals high, then curly parentheses around this one. If beta is high, then before we start the for condition, we're gonna say digital right, no, analog right, and we'll just do the same thing. LED pin, and this is LED pin. Let's control this one, so pin 9. So pin 9 is red. I initialize. I is not initialized up there, so I'm just gonna start one up here. And then it goes into here and gets I value again. So the first one, it might not have anything, but then after that, it should have a value that's similar to the same value as this one. So, oh, but if it isn't, okay, so what I might do is like not put them nested into each other. Take this one out. Put it there. Yeah, so if it's this, it puts the I value with that. But then after it does that, this will get a little confusing with order, but I'm going to put this after so that the I value matches that I value. This is not just a 0. Start. So now that goes blue, but if I click on this button here, oh, did I really? Input E0, yes, that's connected. It's just seeing 1023, start simulation. Why isn't it? It should be going to 1023. That's really strange. Why did it take so long? What? The color's not even changing. Okay, let's just try stop the simulation. LED pin here is just high. Okay, that's correct. Okay, so now this signal right here should be causing a change in the color of that because it's connected to pin red, which is 9, pin 9 red. Did I ever analog right? Yes, here. Oh wait, I did it backwards. It should be high. Where am I typing? What? Oh, stop. This should be I. Okay, so it's going up and down with the blue, but if I push this, let's see what's happening here. Let's try and figure out. So this one here should be, this one's 0, so we don't need that one. Actually, move it here. This one should be constantly changing from like 3.3 to 5, and then this one should be changing from 3.3 to 5, 3.3 or 5, just those two. So start code. Here's the graph. It's not getting up there. Why is it up there? How can I make this? So we can see it. We'll overwrite those states. Okay, that's green and blue mixing. Yep. But if I push this button, this delay is way too slow. Okay, let's just do something here. Stop that. Paste, paste, paste. Capital S? No. We'll get it eventually. Oh my gosh. Did I have this like this before? Okay, so then let's try. Oh my goodness, it's capitalized. Okay, there we go. It's updating here. Red. Okay, that's really strange. Green and blue should be the same number. Oh, this is not the value. Oh my goodness. This is just what the pins are. So I need to write here. Beta. Assumption. Red is determined by beta. And then these two guys are determined by I. I don't know why red is kind of on. Oh, I broke it. There's too much like electricity. So I'm gonna just bring this down to 220. Still stuck in the millivolts. This is not working. For some reason this is not turning on correctly. For that, it will keep doing that inside of itself. So that means I should put this inside of that. Yeah, that's what's happening. So then right here, I'll shove this into here. Okay, this makes a lot more sense now. So red, it has like noise. I click on this, it'll eventually turn 1023. What is this value? Okay. Get rid of the delay. It's just so much noise. So I don't think it was working before because I had to put different types of data, like string data with integer, string with integer, but since I put them on each of their own lines, so print just puts it like concatenated right after each other, so that's why I accounted for the spacing in my text. And then the last one is called print line because it makes a new line character. So it shoves all this data to the next line and starts over. Of course. Oh. And then colon. There we go. But don't know why this is 1013 still. So let's try connecting it to ground. Minimize noise. Code. If beta is equal low, then so blue and green aren't able to do anything. If this is equal to low, do that. If only videos went the way they should go. Okay, all this is good. We started serial thing here, yeah. That's why we can see this. Loop, button read, which is just this. Button read, yeah, it's on or off. Okay. For that, oh, For sure did that. Okay, that's doing what it wants and what we want it to do. And then 255 should set back to 0. We love coding. This is past 2 hours long. Okay, that's good. Now if I push this, nothing. Awesome. So output's working, that helper function is working. The button read, it might just be redundant. So what we might do is just erase this. Get rid of this, we don't need that. And then we'll put it here. Set a button read. That. Beta is here directly. Beta. if beta equals low, run that. Every single time run this. So it resets it to that. It's low. But if it's low, goes here, comes back up here, beta resets it to whatever it read. So if it was low, and then pushing this, okay, so if it's low, then do that. So then that means red is high, green and blue are low. And maybe if I give that also a little delay, we can actually see it maybe. Maybe we're just not seeing it because it's happening so fast. So this is rising, that's still doing nothing. So let's probe another part. Like if we grab this, put this over here. So it's in the same region. Zero volts. And it still stays 0 volts. That's weird though, it should have some noise. Power disconnected to ground. Okay, let's try that. 10k ohm. This is ECE stuff. And you're probably like, oh, we need to pull down resistor. Stop the code. So I need this one connect here to ground. I need to give this one power. Make that red. Color code these a little better. Because those guys make turquoise together. Actually, this one's red. That's confusing, so I'll make this one orange. That one turquoise. Actually, dark blue. Pull down resistor here. Signals goes out to here. If it's powered here, it's gonna have noise leaking into here. Pull down resistor pulls it to 0. So therefore in the code we need to write this as high instead of low now. Write text to trigger high. Okay, so now it's 5 volts. It's reading it, but it's not executing the code correctly. So if beta equals high, these guys should take precedence. If, but it's still running through this. So if that, outside of it else. But I is constantly being changed, so it doesn't get affected by the output. So therefore, I as it gets set to this if thingy, I would also equal. Oh, I would have to be reset. I equals 0. Okay, now why isn't green and blue changing? I and I. Where's my output command here? So oh, it's in the else statement. Output 0 beta I. If it's high, which it is because it was populated with 1023, do that. It's low. These are low states. Reads it. For this. This goes there, this one goes to here, goes to here. This is really strange. I iterated and the state of beta is high. It's just not but it does show it here. this down till 10:23. What happens? I mean, yeah, 2:55. Let's see. It has no effect. It's almost like it's ignoring it. So right now it's going through this. But if it is that, which over here it's saying it's low, so it doesn't go into here, so it goes into here. It's low. But I don't think I need this anymore if I have the pull down resistor. So it shouldn't glow red. Red doesn't matter. Okay. Okay, and over here, do I need these? Low and low. Okay, so if it's that, sometimes you gotta try some weird stuff. So I'm about to try something weird. Wait, what? This is ground. Yeah. Okay, that's 0. That's so weird. It is getting voltage, but these two must be too strong. So the code is working. It's just that these guys are way too strong. Oh. Well, high should work for LEDs. You have the right digital right. Oh, I think I do have the right digital right. Because it's a digital signal. If it was analog, it wouldn't understand what's happening. That's analog because it's a number. 0 volts here, 0 volts there. Just get up to 5 volts there. Outputs and outputs, yeah. Digital right. Analog read button pin. This is really weird. R should be on. Okay, let's make another function called light update. R is the only one that's gonna be digital. The others are gonna be analog. So if it's not high, why is it red? And how is... Okay, so now I have to change the output here to these values. Oh. Okay, 1. It's high, yeah. But it's still fading in and out. Okay, this kind of makes sense. As it's getting closer to 255, 255, 255, it becomes white. So also that's why it looks like it's fading out. That means that it's running the hay block constantly. That's also something else we found out. And it's also running out. It's running this. Let's check if it's running this. Like, so I mute this one. Put before here. It doesn't matter if you put it. Putting it here. Just so it's the same as before. Change this to say rip. If it runs both at the same time. This is semicolon. Wait, what? Oh. Why does it keep doing this? Okay. I'll see a rip. And if I click this, so it's not even going into this. It's not even coming into here at all. If that, if it isn't that, then it just skips it. If it's high, then it goes into here. This is not good practice, but I'm not a coder, so Natasha can't get mad at me. If beta equals high, then it runs that. Still runs hay. Okay, so beta stop. Zero. 1023, yeah. So usually you can just check it with 1023. I mean high, but okay, so it's now running that loop. So it's pure red there. Okay. And then that means it's kind of working. It's just like this should have worked with just 1023. Beta is a analog read. digital read. Okay, so it does exist. So hopefully this is making sense by showing you guys how I go about coding. Why is it stuck at 90? Okay, just holds it at whatever it is at. So when I'm holding this button, that means it's detecting that it's at 1023, which is this loop here. It's low and low. These should replace it, so green and red states have not been reset yet. So I could just be like 0. Because these are not digital, these are analog. Yeah, that's why it doesn't understand. Okay, so 0, 0 for green and blue. That'll make it say 0, like off completely. I think I may have done the backwards. No, I haven't. Yes, I have. So when if it is high on pure red, meaning green and blue should be off. Did it become red, pure red? No, it stays whatever green and blue have been. Output serial. Why does everything freeze up? If it's that, output. If it isn't that, output. If beta isn't high, beta is digital. Beta, where's beta? Beta is digital read. So if it equals low, is this person talking about? Like, what is this type? Like, oh my god, just type like a normal person. Oh my goodness. It holds it. I don't understand why though. Green and blue. They get written to the serial right here, output serial at this time. They just hold whatever's in here. For this, as it iterates through, it freezes up for this as it goes through that. If it's this, if it's that, it just does that, skips over maybe. So that means I have to have this before anything else. Yeah, update. Maybe leave the update down there. Serial stuff comes up. Cut. Zero's the beginning. these. So they should start 0. Doesn't even reset to I equals 0. So that's working now. If it's high, it does that. This is default state with this one being off. And that should be the code now. Yes, blue, red, blue, increasing intensity, red. Restart. Restarts the counter because we have the I equals 0 in that code. It took way too long. But we got it in the end. And let's see if I can do something else here. So intensities can shift. So then if I don't hold the button, instead of it going through this brightness thingy, I'm gonna have we're gonna get rid of this for loop. We don't need it. I'm going to get rid of one of these, I think. Random number. RG. Semicolon's probably somewhere. Nope. Okay. Wait, where I put the Lego stuff. Red. I can now get rid of this debugging thingy. If I want red and blue, that's purple, I think. This should work. Oh, that's yellow. So use high whenever it's digital. Right now we have a digital button controlling analog output. Well, a digital output for red, green, and blue are both digital. Analog output, so they require 0 to 255. Because the equivalent for high in analog high is a 1, I think. So it's not that much. Okay. Okay, and we can get rid of this 0 now, because I think that's beta somewhere. Up serial line. We don't need this. Okay. Then I think there we go. Stop. I think the only thing it lets you go through is comma. Otherwise, I think it might just be 3 different lines. Oh, there we go. So there's the color mixing. Now let's slow it down. Void loop. Delay 250. So actually 100. That's kind of funny. I wonder if the red is even coming through, because it's generating 0 to 255 for red in I1. So if I changed it to 0 and 0, we should just see red changing in intensity. Otherwise, the code is not working 100% exactly what I wanted to. So it's full brightness because digital. Anything that's not a 1, anything that's not a 0 is max value true. So in this case, we need to generate it a 0 or 1. Unfortunately, because we're using digital in combination with analog control. So this one needs to be, I1 needs to randomly mix between max digital, which is 0 through 1, and it's either on or off. So we're not going to see too much color variation with all of them, unless we can I just do this? Okay, so it has the capability of doing it. Max IM1 here. So if beta is low, then randomize it, yes. I2, actually I'll keep it to that so we can see if it works. And then if beta is high, red will be 255. This should work. Okay, so it's changing, yep. Yep, perfect. Okay, I think we got it. We got digital input controlling analog output data structure with 255.0. Now that means if I change these back to I2 and I3, we should see like a rainbow. Like not a rainbow exactly, but just rainbow multicolored stuff. Yep. Then slow there. And we can delay this down to like every quarter of a second. Perfect. Okay, update this last piece of code. And then you can always write in like stuff like written by your name. Okay, and I think that's gonna be the end of this video. It's really long. I will troubling button. This will be in the resources file. But yeah, once you do that, you have this schematic as well as all the parts you would need in order to make it. You don't need the multimeters, but I will leave those there so you guys can play around with it. Okay, that's the end of this video.